CRISPR-Cas9 Part 2. In the first video, we examined what CRISPR-Cas9 was and how it might affect us. In this video, we're talking about the applications. So what can these new genetic techniques do? They're going to affect all of us. So here we go, a 5-minute video on CRISPR-Cas9 applications. So what are the applications of this technology, CRISPR-Cas9? What can we actually do with it? And if you actually stop to think about it, it can make the hair on the back of your head stand up. It's such an exciting technology. I'll give you some examples. First off, malaria. Malaria carried by mosquitoes still kills over 1 million people a year worldwide, usually under 5s. It's catastrophic. Now we have the chance to modify the insects themselves to make them resistant to the malaria parasite. So we don't actually have to touch the humans. We can genetically modify the mosquitoes so that they are resistant to the parasite. So maybe they excrete, for instance, an anti-malarial into their guts that kills the parasite, so they can't transmit it to humans. That's one of the problems solved. But of course, having one mosquito resistant doesn't mean anything. So what you can do is use this precise technology not only to make the mosquitoes resistant, but to put this resistance trait in a place where it's inherited through the population. And these series of technologies are called gene drive technologies. And what that means in a nutshell is you can make these mosquitoes not only resistant, but then you can drive this trait through a population incredibly quickly. Within a few years, in a perfect world, it would spread to encompass the world, or at least a huge area. It's that powerful. That's one application. In principle, it can be done. And I can tell you that it has been done. In the laboratory, resistant mosquitoes have been made and or modified, and they can drive this resistance trait. The reason why it hasn't been released, of course, is because scientists generally are careful. And the people who ultimately make the decision of whether these things can be released will be you and me, society and governments. So they won't just be released willy-nilly. So that's why I think getting these technologies across is so important, because otherwise we're naturally fearful of what is new. And of course, this technology holds potential for the big killers, cancers, dementia. If you can identify specific damage, maybe you could repair the damage using CRISPR-Cas9. You could repair the damage in the cells. Now, this is a bit more tricky, but the potential remains that it can be done. And the same goes for dementia. You could even target cancerous cells to self-destruct with a new set of instructions. That's one potential application. And it's not limited to animals, plants as well. There are huge areas in the world that are going to and are suffering from water shortages. You could potentially make water-resistant crops if you've got the right combination of genes. You can cut out the water-sensitive ones and replace them with water-resistant ones. In principle, all of those technologies. And of course, with relevance to this video, aging. Aging is complex, multifactorial. But again, you can off the top of your head look at skin rejuvenation if you can identify specific damage for the superficial aspects, balding, but then getting more fundamental, osteoporosis, or even more fundamental, the basis of gene repair. That is repairing your genes as to appear when you were younger. That is way off, but the pathway, the potential pathway is there. So it's the application of the technology, and if we can do it. But in terms of medicine at the moment, I think the most practical applications are going to be diseases where single genes are affected. We know there are some diseases, or there are quite a few number, that are just affected by a single gene that's gone wrong. Huntington's disease, neurological disease, there's sickle cell anemia, affects mainly people in sub-Saharan Africa, crippling, it affects their red blood cells, and cystic fibrosis. so affecting primarily the lungs. So these are ones that could really single gene repair. So just one gene could repair the problem. So I hope to just given you an impression that there's pretty much everything is on limits. Whenever we need to manipulate our genes specifically, we can now do it. There are some people who think that we live in the last generation of the naturals. Outfit change. So although this new technology has lots of applications, there are still a lot of hurdles that need to be overcome before it can be used practically in whole animals in vivo. And that, the problems and limitations are what we're going to discuss in the next video, part 3. But do keep watching because this technology will affect us all. Thanks for watching.